Welcome to VGuide TV. In this video, I am giving a shortcut to remember atomic physics. That means atoms. Mostly, the questions from this chapter are based on velocity, radius or energy or the wavelength. So, I am doing those questions. So, remember the equation of radius of the nth orbit. According to Bohr model, we know that electrons are revolving around the nucleus in a circular orbit. So, the radius of the nth orbit we can find by an equation n square h square epsilon 0 by pi me square z. If you are not remembering this equation, we don't want you remember only this equation. The radius Rn equals R1 into n square by z, where R1 is, I remember, 53 picometer. 53 pm, that is 53 into 10 power minus 12 meters. So don't confuse anything. The radius of the orbit, nth orbit, is R1 n square by z. R1 is the radius of the first orbit and it is 53 picometer. The velocity of electron, that also we can find by an equation, z e square by 2 epsilon 0 nh. If you are not remembering this also, no problem at all. Remember the equation V equals C by 137 into Z by N, where C is nothing but 3 into 10 power 8 meter per second. So from these two equations, you understood that the radius is proportional to n square by Z, where Z is the atomic number. Velocity is inversely proportional to, the velocity is proportional to Z by N. That means velocity directly proportional to atomic number, inversely proportional to N. If you need the time period of an electron around the orbit, that is 2 pi r by v, that is proportional to n cube. Many times this question asks t square proportional to n cube. Radius directly proportional to n square. Velocity inversely proportional to n. If time period is proportional to n cube, frequency is inversely proportional to n cube. So remember the basic thing, how to find the radius. Rn is equal to r1 n square by z. Velocity is c by 137 into z by n. And radius is proportional to n square by z. Velocity is proportional to z by n. Time period is proportional to n cube, where our frequency is inversely proportional to n cube. Clear? Now this everyone knows. From here one question surely for physics or chemistry can come. See, when an electron is jump from higher orbit to a lower orbit, it will emit the radiation. So we can arrange their emission lines like this series. First one, Lehman series, Balmer series, Paschen series, bracket series, Fun series, etc. Lehman series is in the ultraviolet region, Balmer series is in the visible region, Paschen series in the short infrared, bracketed in the short infrared, whereas Fun in the long infrared region. Or in short, the last three are in the infrared region, first is in the ultraviolet region. Remember, next. Lehman series means it should jump to the first level, from second to 1, third to 1, 4 to 1, 5 to 1. These all will come under Lehman series. Balmer series means they will jump to 2. Here it should jump to 1. Here it should jump to 2. Paschen means it should jump to 3. So you can write the equation 1 by lambda equals R into 1 by 1 square minus 1 by n square for Lehman series. Balmer means R into 1 by 2 square minus 1 by n square. Paschen means 1 by 3 square minus 1 R into 1 by 3 square minus 1 by n square, and so on. Okay. So we can tell that from here the question surely they'll ask if they are jumping from third level to second level, means your mind should go like it is coming to second level. So it's a Balmer series. Okay. So this equations you have to remember. Now see, for the second level, if you take the first level Lehman series, from 2 to first level it can come, 3 to first level, 4 to first level, 5 to first level, and so on. So the adjacent transition 2 to first level, from the second level to first level, when it jumps, the wavelength will be the longest. But when it jumps from infinity to the first level, the wavelength will be the shortest. Remember the very important thing. Adjacent transition we get higher wavelength, and the far transition we get the shortest wavelength. Clear? So the question from this, they can ask like in which region it can lies or which series it may be. Right? Now another main thing you have to remember is energy of the electron. The potential, we know that This is nucleus of charge Ze and electron is revolving around the nucleus. The potential energy is minus k Ze square by r, where k is 1 by 4 pi epsilon 0 or 9 into 10 power 9. Kinetic energy is k Ze square by 2r. Total energy is minus k Ze square by 2r. By seeing this, we understood kinetic energy and total energy are same with an opposite sign. But the potential energy is nothing but the double of total energy. So we can write total energy is to kinetic energy is to potential energies. Total energy is to kinetic energy is negative of total energy. Potential energy is 2 times of total energy. So we can write the ratio 1 is to minus 1 is to 2 is the ratio of total energy is to kinetic energy is to potential energy. Very important formula. Very important formula. In many exams they ask total energy is to kinetic energy is to potential energy is 1 is to minus 1 is to 2. Clear? Now, we can find the energy of any orbit by the another main shortcut formula, that is minus 13.6 z square by n square eV. Minus 13.6 z square by n square eV. Take the case of hydrogen atom. Z is equal to 1. For hydrogen atom, Z is equal to 1. So you can write the energy level E1 minus 13.6, E2 minus 3.4, E3 minus 1.51, E4 is minus 0.85, like that it goes on. So you see as the energy is getting increased, right? 13.6 minus 3.4 minus 1.51, like that it's going on. So remember this all equation, sure questions. Potential energy, kinetic energy, total energy and the energy we can write in a simple shortcut form minus 13.6 z square by n square eV. Clear? I'll give you 2-3 questions. The radius of the innermost orbit of a hydrogen atom is 5.3 into 10 power minus 11. What is the radius of n equal to 2 and n equal to 3? Direct question I'm giving. Okay. N equal to 2. So you told you the equation as Rn equals R1 n square by Z. They told in the question it's a hydrogen. For hydrogen Z equal to 1. If it is not hydrogen, according to that you change it. So from this you can write it as Z equal to 1 for both the cases. First case n equal to 2, to 2 square. R1 we know that 53 picometer, I told you to remember 53 into 10 power minus 12 into 2 square for the second. If n equal to 3, 53 into 10 power minus 12 into 3 square. Simple thing. So remember the radius relation is R1 n square by Z. Next. A 12.5 eV of electron beam is used to bombard the hydrogen gas at room temperature. What series of wavelength will be emitted? It's a very important question. We are giving an energy of 12.5. Now already I told you for the ground state the energy is minus 13.6. So the electron is in the ground state. Okay, it has an energy of minus 13.6. We are giving an energy of 12.5. So it will absorb, this electron will absorb the energy and it gets a total energy of minus 1.1 eV. If it gets an energy of minus 1.1 eV, I remember in which way I'll tell you. See, if it gets an energy of 1.1 eV, I use the simple shortcut formula. Energy is equal to, I have written here, minus 13.6 z square by n square eV. So right here, my energy is minus 1.1. So minus 13.6 by n square equals minus 1.1. Or n square equal 13.6 by 1.1. That is nearly, I'm getting like a 12.6. If you take the n root over 12.6, that is 3.55. It means that this electron will jump to which level? You know, this is first level, second level, third level. It is going to which level? This electron will go to the third level. When it goes to the third level, we know that it can come back to second level or it come back to first level. When it come back to second level, it is called Bohr series. When it come back to first level, it is called Lyman series. Clear? So what they told, electron was in the ground state with an energy of minus 13.6. We are supplying an energy of 12.5. So it's getting an energy of minus 1.1 eV. With this energy, where this electron will jump, use the formula. So E is equal to minus 13.6 z square by n square. I am getting an energy of minus 1.1. So minus 13.6 by n square equal minus 1.1. N square equal 13.6 by 1.1. That is 12.6. For n is equal to root over 12.6. That is 3.55. It means like this is like we should get like whole number. So I can tell that it cannot go to the fourth level. It can come up to third level, right? So as the electron reaches the third level, there are two types of emission possible. 3:2 or 3:1. So they are the series Balmer and Lehman series. Another question. The electrons of the hydrogen atom race from ground state to third excited state. The number of emission lines is, so another important shortcut formula, number of spectral lines is n into n minus 1 by 2. N into n minus 1 by 2. What is the meaning of third excited state? Third excited state means n equal to 4. So 4 into 4 minus 1 by 2, that is 6. Simple. Which of the following transition is used in hydrogen atom to emit of high frequency? High frequency means high energy, right? So how we can do it is, you can just do it in any form. I have did it in the basic standard form. How I did is, you can find the energy difference of each case. That is n equal to 1, what is energy? N equal to 2, what is energy? By using which formula? You can use the energy minus 13.6 z square by n square. When it is jumping from 1 to 2, it cannot jump, right? So it won't give any emission spectra, because 1 to 2, if it's going, it will be absorption lines. But they are asking emission lines. So first one, no possibility. Okay, second one also there is no possibility. 2 to 6, no possibility. This or this will be. Take these two cases for jumping like this equation. 13.6 into 1 by n1 square minus 1 by n2 square, we can see. And also I told you an important thing, adjacent transition we get. Okay, so you see here, you can just find in this form, h nu is equal to minus 13.6 into 1 by n2 square minus 1 by n1 square. You do it where you are getting more energy. If you get more energy, what will be there? It will be a high frequency, because E is equal to h nu. As frequencies, direct frequency increases, energy also increases. Clear? So in short, I told you, you have to remember the basic standard formula, minus 13.6 z square by n square for energy, and the radius and the velocity relation. You can solve the questions in atoms very easily. Lehman-Balmer Paschen series spectral questions also I told you, that also very important, they can ask from here. Okay, revise of this question to get a better marks or better score. Thanks for watching VGuide TV. Subscribe our channel and press the bell button to get the notifications of new videos. Thank you.